This is physical geology, mineral physical properties for your mineral lab for KPC Physical Geology 111. Just want to give a couple ideas on how to identify minerals using your the physical properties. One is color, luster, hardness, density, and streak, and we'll also be looking at some other properties like taste, magnetism, and the reaction with hydrochloric acid. Hopefully at home you should be using lime juice or lemon juice. Of course, you've already seen the tools that we'll be using here for this lab. And here are some examples of some of the minerals that we'll be looking at that you should have also at home. One thing you'll notice with all of these minerals is that some minerals are the same color. So when looking at color alone is not going to help. You need to be able to look at all of the different physical properties and list all of them before you make an attempt to identify any of these minerals. For example, you can see that all three of these minerals are the same color, and they are three very different minerals. In contrast, this particular mineral right here and right here can come in multiple different colors, and they're the same mineral. Differences in color could be caused by weathering or a different element. For example, this is quartz, and if it was gray, it might have some kind of other element that was infused within that. Amethyst is another example, and that's basically just a purple quartz, or rosy quartz you could have also. So this is just some examples here. So that's one example of color. Another property that we'll be looking at is luster. Two major types of lusters are metallic and non-metallic. And you can see right here, this is a metallic. You can see how it's basically luster is how it reflects light, versus this particular mineral right here is non-metallic. And this is reflecting light, and so therefore it is metallic. If you say something is metallic, then you'll know that basically that's the end of the story as far as luster goes. Some minerals, like this one down here, you could call it submetallic. It does have a refraction of light like a metal, but it's not really as metallic as something like this over here or this right here. So you could also call some of your charts might show a submetallic, like it's almost metallic and you're not really sure whether or not it's metallic. You could call it submetallic. Okay, so for example, this one right here is non-metallic. If you say a particular mineral is non-metallic, then you would want to say that give a second descriptor term for this particular luster. For example, this is non-metallic, 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 non-metallic. All of these right here are non-metallic. So, but you can see that they all look just a little bit different. You could say that this one might be dull, or glassy, or this one right here, you can see it's almost got a pearly luster, and if I refract it just right, you'll see like rainbows, and so that would be a pearly luster. Again, glassy or vitreous. This one too, you could say that would be almost a glassy color, or a glassy luster, but then have a different color. This would be like a salmon color. Again, glassy. You might say that this one right here would be like a dirty luster or an earthy luster. It looks like a hunk of dirt, but it's not. It's actually a rock. And this one right here might be, if you look at it really close, you could see little glass beads. So if you look in your book, you can see that there's a number of different descriptor words that you might use for luster. So that's an example of luster. The third property that you would want to use for a description would be hardness. And we will be using our copper plate, which has got a Mohs hardness scale of 3.5. A nail, which has got a hardness of 5.5. A plate, and this one you can see is very well used, is a hardness of about 7. And we'll also be using our fingernail, which has got about a hardness of 2.5. So if you need to each time always begin with our fingernail, which has got the lowest hardness. So if I take this particular mineral, it's got that metallic luster, but if you can see it chipping off with my fingernail. So that would be a hardness of less than 2.5. So that means it would be very, very soft mineral. And compare that to this particular mineral. I scratch it with my fingernail. I cannot scratch it with my fingernail, so it's harder than a 2.5. Then I attempt to scratch it with this copper plate. Now, if you don't have a copper plate, you might want to use a copper penny, preferably older than 1983. 1983's got more copper than after 1983. If I scratch this, it's hard to do this with one hand because I'm holding the camera at the same time. If I scratch this, you can see it does create some scratch marks. So this particular mineral is harder than this copper plate. So we don't know if it's much harder or just a little bit harder, so we're going to keep on going and see if we can scratch this nail with it. And if I can hear it, and you can see that it scratches the nail. So it means it's harder than a 5.5. So finally, I'm going to use this glass plate, and you can probably hear that as well. It does scratch the glass plate, even though this has obviously been very scratched in the past. So this has actually got a hardness of greater than or about very close to 7.5. So I would call that particular mineral a very hard mineral. And so that helps identify that mineral compared to some of the other minerals here. Another identifying factor for a lot of these minerals is streak. We use streak. Streak is the powdered form of a particular mineral. Now it's really interesting because some minerals might not have any streak, like this mineral here. You would say none, because actually the mineral itself is actually harder than the tile, so it will not have any streak. It will not have streak. Is basically the powdered version of that mineral. Now some minerals, like this one right here, has got a definite streak. You could see that. Silver, you just call that a silver streak. Now other minerals, like say this one right here, you would expect it to have maybe no streak or a gold streak. But if you do it, it might have a reddish streak. So that would give you a definite identifying traits of that particular mineral. Other properties you might want to use would be taste or magnetism or effervescence with acid. Look, watch part 2 of this series to see the effervescing with acid. You should have in your packet a magnet, and all you have to do is go through each mineral and see if it's magnetic. And some will be, there should be one that is fairly magnetic, and that should also give you an identifying factor for that particular one. Please don't taste any of your minerals, although salt is halite, and that will give you an idea of what that particular mineral is. The other identifying factor would be cleavage, and that is basically where the mineral actually cleaves, and that's how it is broken up. You could see that these particular minerals have got flat surfaces, and those flat surfaces are cleaved surfaces. So this one right here, you could see it's a cube. We did not break this way on purpose. It actually breaks that way naturally. This is salt, and it does break in cube forms. You can see the cube forms here. Other minerals might be fractures, and they actually are not cleaved at all. So that's in some examples of mineral properties. Physical Geology 111.